Hello students, so in this lecture we will be discussing about some temperature based sensors, and we will first start with oral, the very common oral temperature sensors that we normally use at our homes. Now this oral temperature sensor is based upon mercury tube. You know the mercury tube. There is a we have the liquid mercury Hg, and inside a glass tube, the glass tube. So this is how it looks, glass tube, and we have the mercury inside it, and there is a normal body temperature point, that is 28.6 degree Fahrenheit. Now, now this temperature sensor is actually it provides a mechanical scale readout. So although it's a temperature sensor, temperature sensor which has a mechanical readout. Mechanical readout. Mechanical readout, you mean the level of the mercury. Now, as the liquid expands, or as the mercury expands, and it pushes up the scale on the tube, so as there is an increase of temperature increase, the Hg expands, the liquid Hg. In the liquid state, it expands, and it actually pushes the scale on the tube. Pushes the scale on the tube, and the scale, as we all know, it is calibrated in Fahrenheit, degree Fahrenheit, and so it converts the physical quantity of temperature into a scale value that humans can read. This is how visual temperature works. Now, the second type of temperature sensor is the thermometer, the temperature sensor that we use to measure the outside or the inside environmental temperature. It is called indoor or an outdoor temperature thermometer. Indoor or outdoor thermometer. Now, it is based upon something called a bimetal strip thermometer. Bimetal strip thermometer. Bimetal strip. Where there are four layers, if we can find out. So there are basically two different types of metals being used. Two metal strips, two dissimilar metals. And they are bonded together in the strip. that forms into a string. So it actually, the shape is something like this. This is where this is where the spring actuator is placed. This is bimetal strip spring. These are the different scales, and this is the spring actuator. And the different temperatures are marked in this way. Say this is 0 degree, then this is say minus 20, this is minus 40, and from here we have an increase in temperature, like this is say 100, this is 120, 140, so on and so forth. Now this bimetal strip, this bimetal strip, it expands. This expands as temperature increases. As there is an increase in temperature, and it rotates the printer to indicate the temperature. Rotates to indicate the temperature. Now, the metals that expand differently with temperature. So, since it is a bimetallic, so the metallic expansion metals, they expand. The expansion is different. And this so as the expansion is different, there exists a force between the spring and the rotator, so it causes a force between the spring, means this one, the spring, and the rotator. That is rotating. And also there is a needle which is actually indicating what temperature the atmosphere is. So there is also a needle. So since it is 20, so there is a needle associated with it. So this is the needle. So it is also under the influence of temperature. So there is a force between the spring, rotator, and which consists of a needle. Now the thermometer scale is calibrated to a known temperature. So initially there is a calibration. Previously existing. Calibration existing. For example, they take the boiling point and freezing point of water, that is basically 100 degrees centigrade and 0 degree centigrade. So that is converted to Fahrenheit. Now these points, they establish the scale, and the device is made into a commercial thermostat. Okay, so they actually are responsible for the scaling, and the device is made into a commercial thermostat. So that is how this temperature works. Next we have the third one, temperature based sensor, is your thermocouple. Thermocouple, the most common example of a thermocouple can be found in the gas lighter at home. The gas lighters that we use for in the natural gas, cooking gas stove. Now these are also called pilot light burners. Pilot light burners. Now they are closed tube system that is containing gas as so there's a closed tube with the gas inside. As it is heated, the gas expands as it is heated, and there is a diaphragm which expands. There is a diaphragm, and also there is a button associated with this burner. So, and the button is also connected to a valve. It's called an open valve. Let's call it as A. Open valve A. Now this, so this is actually in the form of a thermocouple. Now as the expanded diagram and the diagram expands, it actually holds the valve open. So this diaphragm, as it expands to heating, it keeps the valve open, and now the pilot light button can be released because the heat keeps the gas expanded. Now, like the pilot light is burning, any demand of heat from the thermostat with light, the burners and heaters until the demand of the thermostat is met. So this will continue to heat like this, and the demands of a thermostat is met. That means at a certain temperature, this will happen until a certain temperature has been reached. This is what the demand of the thermostat is. Now, pictorially, if you look, this device, it's a little bit complicated. It looks something like you have this is your this is This is from the gas entry point. This is the gas supply. Gas supply, and you have this is where the valve is placed, and this is where the ignition heating takes place, and this corresponds to the pilot light. Pilot light. This one's to the pilot light. It keeps the thermocouple heated. Just keeping the thermocouple heated, and it also burns gas, and the thermostat is in-house demand sheet. Okay, this is what the pilot light is, and this region, or this tube region, is the thermocouple. This is the pilot light tube, or the burner. This is the burner, and this actually contains the thermocouple. This is where the thermocouple gas expands. Thermocouple gas expands. Inside these two regions, we have this gas control module. This is the gas control module, and this is the diaphragm. This is the diaphragm, which expands and keeps this valve A open. This is the valve A. This is the diaphragm here, which is keeping the gas expansion open. Now, if you just plot a diagram of the hot junction and the cool junction, so this is, suppose, is the seal joint, and this is the two metals. This say is the metal A, metal 1, and this again is the metal 2, and this is the hot junction. Let's get hot junction. So in this case, there will be a voltage developed between these two metals. Similarly, the cold junction, or the cold reference junction, will have the same combination of the metals. And in here, if you are plotting the voltage versus temperature diagram here, so put the voltage here and the temperature difference actually between the hot and the cold, and it will provide you a linear plot. However, we need to amplify the output to make it of any use. This output voltage needs to be amplified to make it readable and it to be of any use. This is how this thermocouple works. Now, the next type of thermal sensor, the fourth one, is it's called a thermistor. Thermistor, for the name itself, you can understand it is a combination of resistance and temperature. So it's basically a resistor resistor whose value varies with temperature. So it's shaped up like this. So it is being represented. So it can be represented in two different type of circuits. First one is the voltage output. So we have a voltage like this. So if you place a thermistor here, so it gives you a voltage output. This is how the voltage output is taking place. V out. This is one type of thermistor. Second one is it's basically a voltage divider which produces a varying voltage output. So you can see that it's a voltage divider which is giving a varying voltage. Varying voltage output. Another way where another circuit where the thermistor can be implemented is with the help of is in a transistor. So we have a voltage like this. So we have a same thermistor like this, and this thermistor is again considered to be a transistor. So this is how this is where you get the V out. So this is basically it is used to amplify the current change provided by the thermistor. So it is used to provide the current not to provide, it used to amplify the current change provided by the thermistor. As the temperature changes. Now, one of the disadvantages of this thermistor. So, disadvantage of this thermistor is, as in the case of a thermocouple, unlike a thermocouple, the voltage, the characteristics with temperature, whether it is a voltage versus temperature or current versus temperature, they are not linear. They are not linear. So this is the only disadvantage which needs to be taken care of and using a thermistor. So as a summary of this lecture, we have dealt with 4 different types of temperature sensors. The first one is your normal thermometer or oral temperature, which is based upon mercury. The second one is your indoor or outdoor temperature, which is again based upon a bimetallic spring system. Third one is your thermocouple, where you have two different metals joined, and they are used in different, creating voltage difference, which needs to be amplified. And the last one is your thermistor, where the resistance changes with respect to with respect to temperature. And this has got two different outputs. One is called voltage outputs, and one is called current inputs. And the difference between these two is this one is a linear, provides a linear characteristics of current or the voltage output with temperature thermocouple, whereas in the case of a thermistor, the properties are non-linear. So these are the four different types of temperature sensors.